Pick a direction, any direction. Point at the sky, up, sideways, doesn't matter. Now imagine traveling that way, not flying, teleporting, 1 billion miles a second, just going. You'd pass the moon in less than a heartbeat, Mars in minutes. You'd blow through the outer planets, cross the edge of our solar system, and keep going. After 4 years, you'd reach the nearest star. After 100,000 years, the far edge of our galaxy. After 2 million years, the next major galaxy over, Andromeda, still hurtling toward us on a collision course. Keep going. 100 million years, 1 billion. The galaxies thin out, the clusters fade. The great glowing filaments of the cosmic web stretch further and further apart. And then, nothing. You could travel for 300 million light years and never once pass through a single galaxy. Never graze a star, never come within 1 trillion miles of any atom that was ever part of anything, just cold, dark, expanding emptiness in every direction, as far as physics allows you to see. This isn't a gap between things. This isn't the space between stars, or even between galaxies. This is a void, a cosmic void, and it is one of billions. And here's the fact that every space documentary quietly skips over. These voids aren't the background of the universe. They are the universe. Everything you've ever seen in a photograph of space, every galaxy, every nebula, every glittering cluster, exists in roughly 20% of the total volume of the observable cosmos. The other 80% looks exactly like what I just described. You live in a universe that is, in the most literal sense, almost entirely nothing. And today, we're going in. To understand voids, you first have to understand the structure they belong to. Zoom out far enough from Earth, and I mean genuinely far, hundreds of millions of light years, and the universe stops looking random. It starts looking organized, eerily, hauntingly organized. Galaxies aren't scattered evenly through space. They cluster. They clump together into groups. Those groups collect into clusters. And those clusters arrange themselves along enormous threads called filaments, vast highways of matter that stretch for hundreds of millions of light years. Where filaments intersect, you get the densest, most chaotic places in the universe. Superclusters. Galaxy pileups so massive they contain thousands of galaxies in relatively tight quarters, all pulling at each other, merging, disrupting, colliding in slow motion over billions of years. And between the filaments, nothing. Vast spherical regions of almost total emptiness. No filaments, no clusters, no individual galaxies to speak of, just space, expanding quietly into more space. This is the cosmic web, and it didn't form by accident. Go back 13.8 billion years. The universe is newborn, a nearly uniform cloud of hot plasma, less than a second old, nearly uniform, not perfectly uniform. Tiny quantum fluctuations, variations in density smaller than anything we can currently measure, existed from the very first moment. That's all gravity needed. Over hundreds of millions of years, the denser spots pulled in more matter. The slightly underdense spots lost matter to their neighbors. The rich got richer. The empty got emptier. And the difference between a region that became a supercluster and a region that became a void comes down entirely to which side of that original quantum coin flip it landed on before the universe was even a second old. Structure on the largest scales in the cosmos was decided before the first star ever formed. Our galaxy, the Milky Way, sits on the edge of a structure called Laniakea. It's our supercluster, about 500 million light years wide, 100,000 galaxies, enormous by any measure. And right next door to Laniakea, pressing up against it, like a vast dark ocean against a shoreline, is the local void, about 200 million light years across, and it is not passive. Here's something that surprises most people. Voids don't just sit there, they push. Because a void contains so little matter, its gravitational pull is weaker than the dense filaments and walls surrounding it. The imbalance creates a kind of repulsive effect. Matter near the edges of a void gets tugged outward toward the denser regions around it. The void effectively expels things from itself. Right now, at this moment, the Milky Way is being nudged by the local void, pushed gently but persistently toward the denser heart of Laniakea. Our galaxy is moving at roughly 600 kilometers per second relative to the background of the universe, and part of that motion is the local void refusing to hold on to us. We are being evicted from the nothing. But if the local void makes you feel small, let me tell you about the one that broke the astronomers who found it. In 1981, a team led by Robert Kirshner is mapping the distribution of galaxies in the constellation Boötes. Routine survey work. They're building a three-dimensional picture of how galaxies cluster, and they find a hole, not a small small hole, a hole 300 million light years across, a region of space that, by all models of how the universe should look, should contain roughly 2,000 galaxies. It contains about 60. They checked their data, then checked it again, then checked the equipment. The hole was real. The Boötes Supervoid is so large that if you place the Milky Way at its center, every galaxy within a sphere, 150 million light years in every direction, would essentially vanish. Your nearest galactic neighbor might be 100 million light years away. Your night sky, even with a perfect telescope, would be almost featureless. No Andromeda, no Magellanic Clouds, no great smear of the Virgo cluster. Just your galaxy alone. She's floating in an ocean of dark. For most of human history, if you lived in a Boötes galaxy, you might not have known other galaxies existed at all. The evidence simply wouldn't have been visible. The Boötes void has been called the most dramatic single feature in the observable universe. And standing here, in the cosmic sense, on the wall of Laniakea, looking out toward it, I think that's actually an understatement. Voids are not completely empty. A small number of galaxies do exist inside them. Rogue wanderers that ended up on the wrong side of a density fluctuation 13 billion years ago and have been drifting through the dark ever since. Scientists call them void galaxies, and their lives are profoundly strange. In dense galaxy clusters, existence is violent. Galaxies crash into each other. Gas gets stripped away by tidal forces. Star formation gets triggered in explosive, chaotic bursts, then snuffed out entirely. Galaxies and clusters age fast and die messier. Void galaxies do none of this. Without neighbors to collide with, they evolve slowly, steadily. They tend to be smaller, bluer, a sign of ongoing but gentle star formation, and rich in the gas that denser galaxies have long since had torn away from them. They are, in a very real sense, untouched. While the rest of the universe has been a billion-year demolition derby, void galaxies have just been quietly existing, minding their own business, making stars at their own pace, in their own silence. There's something almost enviable about that, and something deeply lonely. Now here's where this stops being ancient history and becomes a live, ongoing process. The voids are growing. Not just because gravity keeps draining matter out of them, but because of dark energy, the force, still poorly understood, that is causing the universe's expansion to accelerate. For the first several billion years after the Big Bang, expansion was slowing down. Gravity was dominant. Then, roughly 5 billion years ago, something flipped. Expansion began to speed up. Dark energy, whatever it is, was overpowering gravity on the largest scales. As the universe expands faster, the distances between the filaments of the cosmic web stretch. Galaxies that were already far apart get pushed further. Clusters, which are gravitationally bound, will hold together, but the space between them will grow, and the voids will inflate. On timescales longer than the current age of the universe, the picture gets stark. In roughly 100 billion years, the expansion will have pushed most galaxies so far beyond our horizon that they'll be invisible. Not just distant, gone past the boundary where light can ever reach us. The cosmic web will dissolve. Filaments will fray. Superclusters will scatter. The voids won't be separated by structure anymore. They'll simply merge, growing until every last region of space resembles what the Boötes void looks like today. The universe will become one enormous void. Infinite, featureless, cold. Physicists call this the heat death. Not because of temperature, but because every gradient will have flattened. No dense regions, no sparse regions, just uniform nothing, forever, in all directions. The voids aren't a curiosity. They aren't an anomaly. They are the universe's final state, arriving slowly and inevitably from every direction at once. Come back to Earth. Look up at the night sky. Find the darkest patch you can see. The space between stars, between constellations. That darkness, even on the clearest night, is full of things we can't see from here. Distant galaxies, dim stars, gas clouds. It is not a void. But past that, past the local group, past the supercluster, past the thin, bright walls of the cosmic web, there is a darkness that is genuinely, deeply, physically empty. A darkness that spans hundreds of millions of light years in every direction. A darkness that is not waiting for something to fill it. It is the default, the baseline, the thing the universe returns to when structure is given long enough to collapse. We are rare, not just as life, but as matter, as organized, gravitationally gathered, star-forming, galaxy-building complexity. We exist in a thin, bright film on the wall of a bubble, and the bubble is growing. The universe is mostly nothing. We are the strange part. Don't forget that. If this hit differently than you expected, subscribe. This channel exists for exactly that feeling. One question before you go. If you could stand inside the Boötes void and look out, would you want to? Drop it in the comments. I read everyone.